So in this question, we are asked to find the number of arrangements which can be made from 10 letters of the word wallflower if there are no restrictions. And in the second part, it is given that there are exactly 6 letters between the two W's. So this is the restriction in the second part, that there are 6 letters between the two W's. So the first part first, and we are given with this word wallflower. Wallflower. So in order to find out the total number of arrangements or permutations from any word, first of all, you must see that if at all any letter or any digits are repeating. Now here we are given a letter, so we see whether any letter is repeating or not. So you can see that W is repeating 2 times and L is repeating 3 times. So the number of required permutations or arrangements can be found out by taking the factorial of the total number of letters which are in this word, is 10. So 10 factorial, and then we need to divide it by the repeating element, the number of repeating elements. So first we take into account the W. There are 2 W's, so you need to divide it by 2 factorial, and then you need to divide it by 3 because there are 3 L's. 1, 2, and 3. So 3 factorial. And our answer will be by calculating these factorials and then simplifying. You will get 3, 0, 2, 4, 0, 0. So these are the total number of arrangements which can be made from this word wallflower, and there is no restriction. Now in the second part, it is given it has been imposed a restriction that there are exactly 6 letters between the two W's. So let's take this W here and this W here. So there must be 6 letters between these two W's. Now, as you know that this word contains 10 letters. So if we can take these two W's here, and there are here 6 letters according to the condition, in between the two W's there must be 6 letters. So one letter, second, third, fourth, fifth, and sixth. So these are the places where you can place those 6 letters. Now, as you can see that there are 10 total letters. So we have to complete because one arrangement contains 10 letters. So these are 6 elements or 6 letters. 6, these 2, 8. So where we should be placing the other 2 letters. So either the 2 letters may be placed here, or now this is the ring 1, 2, 3, 4, 5, 6, and W. This is the required arrangement. Okay, and either you can place the 2 remaining letters here before the first W, or you can shift these 2 letters here, or again you should be writing the compulsion part first. 2 W's and 6 letters. So 1, 2, these dots represents W, letters rather. 1, 2, 3, 4, 5, and 6. Now one letter may be placed here and the second letter may be placed here. So this is our compulsion part. This is our compulsion part. 2 W's and 6 letters in between. 2 W's and 6 letters in between. 2 W's and 6 letters in between. And just the total number of letters are 10. So the other two letters may be placed before the first W, or it may be placed after the last W, or one of those letters may be placed before the first W and the second letter may be placed at the last. That is after the second W. Because the total number of letters must be equal to 10. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now we will be finding the number of different permutation in each case. So we need to find out the permutation in this case, and the number of permutation in this case, and again the number of permutation in this case, and the number of permutation in this case. So first of all, here in this part, that what are the number of different permutations or arrangements which can be formed with this arrangement. Now, as you can see that W's are fixed, so there is no need to take into account these W's. How many letters are left? So if you exclude these two W's, I am excluding because their position is fixed. We need to just permutate the other 8 letters in order to find out the different permutations. So we have got 8 letters. So here is our word, and if you exclude this W and this W, so you are left with 8 letters. So in order to find out the permutations of the 8 letters, with some elements are repeating, and if you exclude W, still L is there, and L is not once there, it is thrice there. So you need to write first of all the total number of letters, that is 8 factorial, and divided by the 3 L's. Because there are 3 L's, you need to divide it by 3 factorial. So these are the total number of arrangements which can be made if 6 letters are between the 2 W's and 2 letters are before the first W. Similarly, you can able to find out the number of permutations in the second scenario, in which the 2 remaining letters are in the last, it is at the last. So again, you can find out that the total number of permutations will be 8 factorial divided by 3 factorial. Similarly, in this case, the answer will remain the same. It's 8 factorial divided by 3 factorial. So what are the total number of arrangements? Simply add these arrangements. So this arrangement with this total number of arrangements, this total number of arrangements. or you can just multiply 3 with the 8 factorial over 3. You can get the answer. So our answer will be 3 multiplied by 8 factorial divided by 3 factorial. And that will be equal to 20160. 20160. So these are the total number of arrangements which can be made from 10 letters with the restriction that exactly 6 letters lies between the two W's.